that Robert has joined us today. Robert, maybe you can give folks just a little bit of an introduction before Quiet Creek goes away and Arizona GIS is born.
Well, thanks, Jenna. I think just about everybody, you know, I'm looking over the list and I see some old friends in there and maybe some new ones. But, you know, so I graduated from the U of A with an MS GIST degree in, oh God, I want to say 2015. And then later on, I got from Penn State University a certificate in Earth observation and remote sensing. We started up the Quiet Creek Corporation in 2015 as a drone service provider, and have recently given that up for a variety of reasons. But really what we've been doing over the last several years is kind of turning the remote sensing stuff into what humans can understand or perceive and get value from. And that's kind of where we've found our niche in this whole thing. And included in that, you know, it's, if you ask me, I'll tell you, it's all remote sensing. This LiDAR stuff and the satellite stuff and the drone stuff and the airplane stuff, it's all remote sensing. So really, you know, if you're looking for a new name, this could be called the Remote Sensing Working Group, and all of that other stuff would fall nicely into it. So there you have it. So we're switching to Arizona GIS, not for any sort of nefarious reason, but just it's a better structure for a company our size. We're going from an S corp to an LLC, so that's the reason for it. And it was easier to just make a clean break instead of trying to reclassify a business. It's just easier to shut it down and start up a new one. Welcome to my world. So that's my introduction. You know, hello to everybody, and thank you for giving me the opportunity to talk about remote sensing. Some good remote sensed data, which is kind of implies that there might be some bad remote sensed data out there, and maybe I'll touch on that just a little bit. So here's the agenda. Having titled my brief "Good Remotely Sensed Data," I'm going to define that, and then I'm going to tell you how to get the good stuff. And then I'm going to give some examples on how to use that good stuff to make a website or some sort of interface that a human can use and understand and download and get some value from. And off on the right there of my agenda slide is kind of what I'm talking about. You know, there we have a plot of land somewhere, and I'll discuss that in a minute, but, you know, we have non-tree vegetation percentage, non-vegetated percent, and tree canopy. And there's two others that didn't make it to the slideshow. But I mean, that's 20 years of data that we're describing there, and that's from satellites, and that's something that a human can understand on the right of the screen, and that's kind of the objective. So, how do I define good? Number one is it's free, and I put that in quotes, knowing that we just got through a discussion about how much this stuff costs and all of the funding and all of that. But to the end user, it's essentially free. You go to the you know, Earth Explorer or something and you download it, and it's free. There's nothing really required financially. You know, over the years they kind of go back and forth. They, being the USGS, I guess, goes back and forth with, you know, charging people for a Landsat scene, for instance. I think that discussion kind of went away when the Europeans put up a rather good satellite system and started providing that for free. So The second requirement that I have is it needs to be rigorously developed. And sometimes this is called analysis ready. And this is really the tricky part of the whole remote sensing thing. Rigorously developed means that it's gone through a series of steps that make it radiometrically corrected. And let me give you an example of what I mean by that. So you're sitting there in the couch in your living room, you got your feet kicked up, and you're just about to turn on the 60-inch TV there, and it's got a black screen. And behind you somewhere, there's a lamp. And if you look at that black screen, before you turn it on, if you look at that black screen, you're going to see the reflection of that lamp. And it's going to be a bright spot on the screen. In fact, even after you turn it on and you're watching some show, you'll still see that if you look for it. And what that is if you take that to a remote sensing view, what you're looking at is you're looking at that thing behind you, that lamp behind you is the sun. You're the satellite, and the screen is the Earth. And there's that bright spot created by the sun on the Earth that you're seeing. If you don't correct for that, then your data is not radiometrically corrected, and you're going to run into trouble if you compare one screen to the next screen year after year, month after month, or even every 5 days or 8 days, depending on your temporal resolution of your sensor. So there's a process called bidirectional reflection distribution equation. I think I've got that right. Function, I'm sorry, BRDF. And it's complicated. It really is. And it's often too complicated. Well, it's too complicated for me, but it's not too complicated for the folks at the USGS and others. And so, for instance, all of the stuff, not all, but most of the satellite stuff has got when you go to the download screen on Earth Explorer, for instance, you'll see something called ARD, and that's the analysis ready stuff. And that's the good stuff. It's been radiometrically corrected. And so when you compare one image from, last week to one from 10 years ago, and they're both ARD, and you see an NDVI increase or decrease, you can take that to the bank and say, yes, that's true. Instead of, I'll give you an example. Somebody goes out with a drone one day, it's a nice, bright, shiny day. They go over a couple 100 acres of territory, and they say, here's your NDVI. It's great. 2 weeks later, they come back, and it's a cloudy day, and they fly the drone, and they produce an NDVI, and they go, oh, man, that's terrible. Your crop is dead. It's not. What's happened is they haven't done the radiometric correction, and that's what's being done by the USGS and others. Okay. I've talked about that enough. Oh, just one more thing. On that, NAEP would not qualify as the good stuff. Even though it has some great characteristics, it is not rigorously developed. So it does not have, you compare one NAEP to another NAEP, you run a risk of a data comparison that may not be true. The other thing that is included in my definition of good is temporal depth, and that is how far back does the data go, or will it be continuing forward into the future? With Landsat 9, we're in a good position with going forward in the future, and we've got 50 years behind us with the Landsat stuff. So, and there's other satellites up there as well. In fact, I'm not even going to be talking about Landsat, but more MODIS today. So, for example, here's a data set that I've got up on the screen. It's called Mod 13A1, and what that translates to, and we'll get into where to get this good stuff in a minute. But that's a 500-meter NDVI. And 500 meters in this day and age of, we were talking about 30 centimeters before, but 500 meters sounds ridiculous. But when you're looking at a landscape scenario, you're trying to make decisions of a landscape. 500 meters or 250 meters is fine. So there's a 500 meter NDVI. It's free. It has an accuracy of 0.025 plus or minus, and a temporal depth of 21 years every 16 days. That's an awesome data set. There's no two ways about it. It's really a cool data set, and there's dozens of these kind of mod data sets. There's night sky stuff. There's NDVI. There's just about any of the indexes that you can imagine they've got one for, and it's all done for you by the USGS. And I'm not a shill for the USGS, but it's all done for you, and it's available for free. So here's how you get it. You need a log on to get the data. You can go through the AROS registration system. To do that, you can Google LPDAAC, which stands for Land Process. I'm going to read it. So Land Process Distributed Active Archive Center. And then you open that, search the data catalog. And in this particular case, we typed in NDVI, click the data set you want, then there it is. So, and off on the right, you got download data, and it's as simple as that. There's a different way of doing it, and this is a web app called Appers, and I'm going to read this too, which stands for Application for Extracting and Exploring Analysis-Ready Samples. So that just sounds exactly like what we want to do, and it does. So you can draw a little box there that I've done here. You draw a box and you say, I want the data from that, and it asks you it's got down here, it's got the start date and the end date. This is, I don't want to get into too much detail on this because I think everybody in this audience, well, let me tell you, I was briefing not this, but something to the Oregon-California Trails Association the other day, and I think I'm a member of that group, but I think a lot of those people did come across the country in 1850. So I had to go step by step on a lot of this stuff, and I don't think I need to do that with this group. But if you start getting into this and start looking around at the stuff that's available, I think you'll be amazed. Here's some stuff that's just available in that area that I just picked. That you can download and get for free. And I'm going to pick Mod 44B. In this particular case, for that box that I picked, I'm going to pick Mod 44B, which is kind of a cool data set. And that's what this is. It's a yearly data set since the year 2000. It's a USGS product. It's based on MODIS. It has a 250 meter spatial resolution. And for each cell, it's a multi-dimensional raster that you get. For each cell, there's the percent tree, percent non-tree, and percent bare earth is given for each cell. And Mark mentioned, the ArcGIS Pro tools, and they have gotten quite good at handling this kind of stuff. So don't be afraid of the multi-dimensional raster. There's tools built into ArcGIS Pro that can handle that. I think also with ArcMap. So you download the multi-dimensional raster, and then you can put it into some sort of a website. And that's what I've done here. I'm going to just kind of move to that website there. And we did this for the Altar Valley Conservation Alliance. And that's the Altar Valley Conservation Alliance's area of interest there. And that green stuff in the center, that's the non-tree vegetation percent that we're looking at. So what we've done with this app is we've taken that data, all 21 years, I think, and we've stacked them all up. And that's the data that you're seeing there. So for that entire area, we've got 44.6% is non-tree vegetation, 52.2 is non-vegetated. There's tree canopy. This is actually another data set, as is this, as is this. as are these over here. So let's just focus on these first three. So you can take an area in here, and if you zoom in, here are those nice square 250 by 250 meter cells. And as you move around and zoom in, all of these things are going to change based on what you're looking at, including the PRISM data. PRISM is from the Oregon State University. It has it classifies as good data because it has temporal depth and it's rigorously constructed, and it's free. So you can even pick on a single cell in here and get the data specifically for that cell. There it is. Thankfully, that popped up, and I've got a bunch of different layers from different products here, but there is the data for that particular cell going back 20 years, and you can make it simple on yourself and just zoom in, close that out, and you'll get, if you zoom in onto the one cell, this is the data for that one cell. You can also take something. This tool up here that ArcGIS provides, a lasso, and go around an area, give it a couple of seconds to figure that out, and there it is. So it's, this is the data in there. And there are the graphs on the right. So that's something that a human can understand. Now, and I'm going to switch now to this. This is even better so what I did there is I took that free USGS data and I mashed it into something that could be used in ArcGIS Online, which is not particularly good for showing this kind of data. On the other hand, something called Earth Engine, Google Earth Engine, is good for showing this kind of data. And what we have here is that same area that I showed. But I've taken an area out here, I've drawn a rectangle somewhere else, and this is worldwide. And I've clicked on that and drawn a box, and it's generating a chart. Hopefully a chart shows up, and there is and this is that NDVI that I mentioned before, the 500 meter NDVI. This is the 500 meter NDVI average of this square for the last, 20 years. And that's really cool. You can expand it and see the graph, and you can make some, you could become scared by looking at this stuff over here on the right, the recent stuff, and then you can download this all to all of this data going across to a spreadsheet of some sort. So that's worldwide. So all of Arizona is included in that set. So I'll just take a moment to wrap up and then kind of ask for your questions. And I hope there are some questions. But I defined what really good is, or good data, and there's three components to it. It's got to be free. It's got to be rigorously developed, and it has to have some sort of temporal depth, hopefully going in both directions. And then I gave a couple of examples of how to use that data, both in an ArcGIS Online environment and a Google Earth. The disadvantage of Google Earth, and I'm sorry I didn't mention it, the disadvantage of Google Earth Engine is it requires some sort of knowledge of JavaScript, and that's not particularly hard, but it's a very, as I have found, it's a very perishable skill. So if you're not using it all the time, and you are using something like Python, which I do use quite a bit, going back and forth is not particularly easy. So that's the disadvantage of Google Earth Engine. However, the great advantage of Google Earth Engine is you could set these things up, and if you had the time and the energy, you could set these things up in a statewide kind of model, and you could, have a number of these for analyzing data statewide. And Google Earth Engine, by the way, uses the exact same data. They just pull the data from the USGS, so there's no degradation of any of the data as it makes its way from Google Earth for the USGS and Sentinel into Google Earth Engine. Okay, I am going to stop sharing and ask for questions. I got one question already from Mark.
Robert, great presentation. I was really interested in that 250 meter grid, because my immediate thought is I could do that for my 3 districts. You had up like mod 44B. How do you find, how many mods are there? It seems like there was a lot of them. Like, is there a list?
There's dozens.
Sort through and figure out, okay, I want this one kind of thing.
There's dozens of them, and they've got Mark. If you go to that site, the LPDAAC, if you go there, you'll be able to see all the different ones, and it's metadata rich. So you'll be able to look at the metadata and say, yeah, I want this one, or no, I don't want this one.
Gotcha.
So,
do you have your top 5 like that you like to play with, or?
Yeah, well, that one that I showed with the it's a mod 44B. That one is really good because it's a multi-dimensional raster. It has those 3. It actually has like 9 different components in there. It's got a standard deviation of error and a whole bunch of data. But those 3 are very good. And I'll tell you, Mark, you will. Because of the resolution and because of, there's other stuff out there that kind of satisfies that itch, like Landfire does a great job of, what's bare earth and where are trees and some of the data won't line up precisely. So you get something like Landfire, which is 30 meters, and then you get something like, this, which is 250 or 500 meters, and it won't line up, and people will be turned off by it. And I understand that. But the key is with all of this is to look at the trends. Because it is rigorously developed, the trends are going to be true, regardless if I had one person come up and say, well, I know there's more trees in that pixel than what you're showing, and okay, fair enough. But the trend is true and good.
Yeah, we've been looking a lot at trend data for the range programs. With the U.S. Forest Service, we tend to focus on our trees, but there's a very active, range management program, and therefore we care a lot about, individual moisture levels, and is that in turn growing grass for the cattle kind of thing. And so we've been looking at temporal drought and understanding seasonal variations to help our allotments out kind of thing. So we've been looking in that direction. So cool.
Yeah, that's a great idea, and others are looking at that too as well, Mark. I mean, the Ultraviolet Conservation Alliance, their monitoring program is switching to something like this, and it's not particularly simple to do, but it is I think a great way forward for resource monitoring, because it kind of takes that subjective. And I have asked the question about, okay, there's in the what is it, the 𝐸𝐸 data, it has the range forage production potential for each ecosite, and I've asked the question, well, where does that come from? And that's a question you don't really want to ask, because the answer is kind of subjective, where that comes from. And so I think, if you were to put a stake in the ground somewhere and say, we're going to start using this suite of satellite data going forward, I think you could see some benefit from that.
Yeah.
Anyone else? Any comments, questions for Robert? That was excellent, Robert. Thank you very much.
Thank you.